So hi everyone, welcome to the Aerospike Virtual Summit, and thanks for logging into this session, Aerospike Cloud for Developers. I am Panchabakesan. You can also call me SP, and I am a software engineer and part of the ecosystems engineering team at Aerospike. So we can start the session. So first, I would like to talk about what is Aerospike Cloud. So you may have recently seen a few blog posts about Aerospike Cloud on our website and what what is Aerospike Cloud and what are the things that it offers. So Aerospike Cloud is a group of software products and services that help you to accelerate the development, management, and automation of your own Aerospike database as a service. So we have tools and components part of the Aerospike Cloud that help you to simplify uh, the deployment, the orchestration, monitoring, and management of your overall Aerospike cluster across different platforms, whether it's cloud, hybrid cloud, or the bare metal servers, etc. So that's the URL on the slide, which takes you to the product page where you can find where we introduce the Aerospike Cloud. Uh, so feel free to check it out. Aerospike Cloud uses tools that are supported by CNCF, which is Cloud Native Computing Foundation, such as Helm, Kubernetes, Prometheus, and so on. So Aerospike Cloud, with the initial release, it offers the Aerospike Kubernetes operator, which is in beta phase. We also have Aerospike Helm charts, which is GA, general availability, and Prometheus and Grafana-based monitoring stack, and along with our own Aerospike Prometheus exporter, uh, which is also in beta phase, and the marketplace offering on Google Cloud Platform for both the Kubernetes engine, GKE, and the GCE, the Compute Engine VMs, so which is also in general availability state. So all these may seem like the terms for ops, sysadmins, and SREs, but I'm going to talk about how Aerospike Cloud can be used by the developers. Yes. So the Aerospike Cloud components involve for designed keeping in mind that they are for production ready. So there's a lot of automation involved. And yes, so for example, if you take the Aerospike Helm chart, you just have to run a single command which deploys your Aerospike cluster on top of Kubernetes. The Aerospike Kubernetes operator, which runs an operator pod that can manage your Aerospike cluster and take automated actions with Aerospike's knowledge embedded in. Uh, and the marketplace offering, all of them are click to deploy. So you just have a UI where you have to give inputs and click deploy, and your Aerospike cluster will be deployed along with the provisioning of VMs and your Kubernetes servers, Kubernetes engine. So yes, it's quick and easy to provision a multi-node Aerospike cluster on across all platforms in just seconds. And as you can see, Kubernetes is involved a lot in the Aerospike cloud. So I'm going to talk more about Kubernetes and how Aerospike on Kubernetes can be used as ultimate development environment. Because having a multi-node Aerospike cluster deployed and ready for for developing applications is imperative when it comes to running integration test, uh, or if you want to test some scenarios where your production and dev must match. So it's very useful. And yes, it's developer friendly because more automation, so less ops work. So let's get started. Let me quickly mention the tools and utilities that I'll be using, that I prefer to use to set up this development environment. So first, I would require a container runtime for my Kubernetes cluster. So I'll be using Docker for that, and Minikube, which helps to set up a local Kubernetes cluster, and the Helm command line tool to deploy the Aerospike Helm charts or any other Helm charts, and kubectl, which is used to run commands against your Kubernetes cluster. So let's move on to setting up the Kubernetes environment. So setting up Kubernetes environment is very simple. You just have to run one command, which is minikube start, and you have your local Kubernetes cluster up and running. You don't need to rely on ops teams to provision any servers anymore. Every developer gets their own Kubernetes, and you have your environment up and ready in seconds. So note that I'm specifying a driver as none in this case, which will use the Docker engine directly on Linux. If you're on Mac and Windows, you may want to use a virtualization layer, virtualization driver, such as VirtualBox, VMware, KVM, HyperKit, etc. So yes, so just one command and your Kubernetes cluster is up and running. And yes, next we can start deploying the Aerospike cluster. So let me talk a brief about the Aerospike Helm charts, which we will be using to deploy the Aerospike cluster on top of the Kubernetes environment. So Aerospike Helm chart is available on. You can use that link to find the charts for both community and enterprise edition. If you want to know more details on how the stateful set, Aerospike stateful set is packaged and what are the components involved, or the source code, you can visit the GitHub repos mentioned for both enterprise and community edition. So yes, with Aerospike Helm chart, it's quick and easy to deploy an Aerospike cluster on Kubernetes. The features of Helm charts include that it supports different Aerospike configurations. You can deploy the Aerospike cluster across all Kubernetes platforms, whether it's on cloud, Amazon EKS, the Google GKE, the bare metal servers if you have formed your own Kubernetes cluster. And yes, so it also supports the Aerospike cluster security, which is the access control feature. It also supports quiescence for smooth scale down. Quiescence is the feature of Aerospike where you can scale down your cluster, your applications don't get timeouts. And yes, Helm chart also includes the Prometheus exporter as a sidecar container, which is optional. You can use a command line flag to enable the Prometheus exporter. And yes, you also have an option to deploy the entire monitoring stack, which includes Prometheus, Grafana, and Alert Manager. There are multiple ways. Yes, Aerospike Helm chart supports multiple ways to expose the Aerospike cluster. This is required for the applications which are outside your Kubernetes network and cannot access the Aerospike cluster directly. So I'll be talking a bit more about the last feature, which is the multiple ways to expose Aerospike cluster, and in the upcoming slides. So yes, so this is all about the Aerospike Helm chart. And next, let's look at how to deploy the Aerospike Helm chart, or your which is effectively deploying the Aerospike cluster. So you can deploy the Aerospike cluster with just two commands. One is to add the Aerospike Helm repository locally. So for that, you can simply run Helm repo add, the repository name and the repository URL, and then you can deploy the Aerospike Helm chart using Helm install command. And so here you can see Helm install. There is a release name or the deployment name, which is Summit, and you have the chart name. And for enterprise, there is an additional config option to specify the features.conf because enterprise edition requires a feature file to start. So that's it. You just have two commands, and your Aerospike cluster will be deployed and ready. So next, I'll be going to talk about the networking or the ways to expose the Aerospike cluster. Because yes, so when you're outside the Kubernetes network, the question comes up: how do I access my Aerospike cluster? So let me put the problem first. The problem is that when Aerospike pods are launched, they'll be launched in a private address space inside your Kubernetes network. So you cannot directly access them with the IPs. So what you need to do is you need to find a way to expose each Aerospike pod so that it can be accessible from an external endpoint outside the Kubernetes network. So we have three methods. One is the host networking. So it's similar to your Docker host networking. So when you enable the host networking, pods will be launched directly on Node's network, and the pod IP will be same as your Node IP, and the Aerospike port will be directly opened on the Kubernetes host. So for that, you can simply enable a flag called host networking equal to true and specify the platform as GKE or EKS, or if it is bare metal, you can specify the platform as none. So yes, so with this, you can launch pods with host networking enabled, and there is a limit. There is a drawback that you can only spin up one pod per Kubernetes host when using host networking due to port conflict. So if you have okay, so the next method is the node port services. Uh, so the Kubernetes provide node port services which you have to create for each Aerospike pod. The pod gets exposed via the node IP and the node port. Uh, so that's the endpoint. So applications can connect to your Aerospike cluster using the node IP and node port. So you don't have to do it. The Helm chart will create it for you. So you just have to set the flag enable node port services equal to true, and the platform has whether you are on GKE or EKS. There's also additional flag which is called rbac.create equal to true. RBAC is or RBAC, which is role-based access control. It's just required to create a service account that can query the node port service objects. So you don't need to know the technical details if you're just setting up a development environment. And if you don't know anything about Kubernetes, that's fine as well. You just have to use these flags and your environment will be ready. So last method is the load balancer services per pod. So this is specific to cloud. So if we set this flag, enable load balancer services equal to true. So this will provision a network load balancer, and you will of course be charged for the load balancer. So for setting up your development environment, you may not need this option to do cost cutting. And yes, but yeah, so on cloud, you can use this option. This will create a load balancer for each Aerospike pod, and the applications can connect to the Aerospike cluster using load balancer IP and load balancer port. So next, the question comes up is how do I persist my development data, which is effectively the storage configuration. So yes, so by default, in Helm chart, the Aerospike configuration that is used is a file-based storage configuration, and on the Kubernetes level, it's an MTDI volume. So the volume is ephemeral, so it can survive only as long as your Aerospike pod is alive. So when you take down the pod, the volume goes away. So it's not persistent. But what you can do is there are other options where you can make the storage persistent. So if you're using Minikube, Minikube comes up with a pre-built host path provisioner, and it has a predefined storage class that's standard. So we can use the storage class directly to provision volumes, and we can use that volumes for file-based storage in Aerospike configuration. Because it's a host path provisioner, it just creates a directory on your Kubernetes host. The path is /temp host path provisioner, and when you create volumes for the Aerospike pod, and the Aerospike namespace data files will be accessible through this path from the Kubernetes host. So it's very convenient for development, but the restriction is that you have to use file-based storage when on Minikube. But on cloud, things are different. On cloud, you can make use of the dynamic provisioning, which is the on-demand request of your storage volumes. So for AWS, it will be the EBS volumes you can request on demand, and for GCE for GCP that will be the GCE persistent disk. So this is an example of a storage class where you can see the provisioner as on the left side you can see the provisioner as AWS EBS. So this can be used to request EBS volumes, and the type is general purpose disk. You can also request for the provisioned IOPS SSDs, which is a type IO1. And similarly on GCE side, similarly on GKE side, you have a GCE PD provisioner, which you can use to request the persistent disk on demand with dynamic provisioning. The type includes PD SSD, which are more performant than PD standard. So that's on cloud. So just remember that these are just storage classes, and later the upcoming slide will have how to use the storage classes to request volumes for our Aerospike pods. Okay, so next is how can you make use of the local attached SSDs? So it's a big example for which I have written an article on our website, which is available on our website. So you can visit the URL which mentions the deploy guides for Kubernetes, and you can find a good example which has which uses the Aerospike Helm chart and the local static provisioner, which is developed by the Kubernetes SIG, which is Special Interest Group. So they have developed a local volume static provisioner, and the example uses that, and it gives you a storage class uh, which you can simply feed it into the Aerospike Helm chart configuration, and you can make use of the local attached SSDs or disks uh, for the Aerospike cluster. So it's almost equivalent to the dynamic provisioning, but it's limited by the number of devices available. You can also make multiple partitions to increase the number of devices. And yes, it works for all platforms, whether on cloud, whether on on-premise servers, whether it's a hybrid environment, or even your local workstation. So that's about the different ways to configure storage, and this is a quick example of how to apply those configuration in your Helm chart. So you can so there is a values.yaml file in your Helm chart, and you can simply go and edit that file and add the volumes that you want under persistent storage configuration, which is used for dynamic provisioning. You can specify the storage class, which I mentioned in the previous slides, and give some volume name, give a mount path that you want to be accessible inside the container. And yes, the access mode read write once is actually tells the volume that it can be read write by a single node. Again, yeah, you don't have to know too much details if you have not used Kubernetes, that is fine. But just a quick example to how to configure all this. You can specify the volume mode as file system or a block device, and the size of the volume. And similarly, on the right-hand side, you can see how to do the static provisioning. So a good example is how to use a volume which is mounted to your Kubernetes host. So if you have a big device that is attached to your Kubernetes host, you can simply mount it to a file system and give the path in the host path configuration, and your namespace data files will be accessible on this path. So that's about the static provisioning and dynamic provisioning via Helm chart. And yes, so how do you apply the changes that you did to values.yaml file? So you can simply apply it using -f option during Helm install, or --values option. So you can use both and pass in the modified values.yaml file. And you can also do the entire thing on the command line, since it's an array of so it's a list of volumes which is sent as which is given as input to the persistent storage. So you have to do something like persistent storage of 0, persistent storage of 1 on the command line. So it's better to use the values.yaml file rather than writing a huge command. So that's about the storage configuration. Let me do a quick recap. So it's not that difficult to set up a development environment. So we just did 3 commands, which is minikube start, which provisions your Kubernetes environment, and next is add the Aerospike Helm repository, and third is use Helm install to deploy the Aerospike cluster on your Kubernetes environment. So here I'm not using the storage configuration because it's optional. It's only when you want to persist your Aerospike namespace data. So that's it. We have our environment ready. So what's next? Next is we can start developing the Aerospike applications and make use of this environment. So for that, if your application is outside your Kubernetes network, so you can simply so you must enable one of the ways to expose the Aerospike pods. So in this case, I'm using the node port. So you have to give the seed port in your application as node port, and seed IP as one of the Kubernetes node IP, which in this example is the minikube host IP. And you have to tell the client that you have to use alternate services for client discovery. So that's just a simple config in your client policy to set use services alternate. This is an example for Python client. The exact config name may change depending on the client library that you're using. So that will make use of the alternate access address or the node IP and node port for the cluster discovery, and you can easily connect to your Aerospike cluster that is deployed on the Kubernetes environment. So this is one way where your application is outside the Kubernetes environment. Next is another method where you can also deploy your application inside the Kubernetes cluster as a pod. So what you need to do is you have to package your application as a Docker image with simple Docker file, and then just say similar to your Docker run or something like kubectl run, so you can directly deploy your application as a pod inside your Kubernetes network. So when you are deploying your application also in the Kubernetes cluster, you don't have to uh, enable the node port services or any other ways to expose Aerospike pod. You can simply use a DNS name or the Aerospike pod name and specify the port as 3000 directly, as you can see in this example, and your application will be able to connect to your Aerospike cluster and work fine. So another thing that I want to mention is if you want to access your application also uh, outside the Kubernetes network, so you can simply expose the application pod via a node port service, or you can also use a simple kubectl port forward and just specify the pod name and a port that can be accessed on localhost, and then the port that the application is using on the pod. So here in this case, simple kubectl port forward will forward traffic from my localhost 8000 to the pod to the port 8000 of the Motogp pod. So that's it. So accessing the application is also pretty simple. So next, let's go on to the demo. So I have prepared a demo which uses Minikube to set up a local Kubernetes cluster, and then uses Helm chart to deploy an Aerospike cluster on top of it, and then an example web application that can use the Aerospike cluster as storage backend. So let's look at the demo.
Hi. So let's set up a local Kubernetes environment using Minikube. So I'll just run one command, which is Minikube start, and that should set up my local Kubernetes cluster. So here I'm using a VirtualBox driver because I'm running on Mac OS. And if you're on Linux and if you have Docker Engine pre-installed, you can specify the driver as none. That will make Minikube use the Docker Engine directly to set up the Kubernetes environment. There are a lot of other VM drivers and virtualization supported by Minikube. So let's take a quick look on the Minikube docs and see what are the virtualization available for different OS. So we have VirtualBox, KVM for Linux. There are a lot of other options as well. HyperKit, VirtualBox, and VMware for Mac OS. There's VirtualBox also for Windows. So we have quite a good amount of options for different OS. So you just have to choose one based on your preference and OS and specify it in the Minikube start command. Okay. So I have my Kubernetes up and running. The Minikube start command ran successfully. So I can also check the status of my Kubernetes cluster using Minikube status. The output looks good. The host, which is Minikube VM, is running fine. Kubelet and API server are running fine. Kubeconfig is configured. So I'll go ahead and run kubectl get all for all namespaces to see the resources that are running on my Kubernetes environment. So I have a bunch of pods which are running. There's core DNS, there's etcd key value store, API server, controller manager, there's kube proxy, and kube scheduler. So all the pods are running fine. Everything looks good. Now I can start deploying my applications and the Aerospike cluster. Now I have my local Kubernetes environment up and running. Next, I'll go ahead and deploy an Aerospike cluster on this environment. To do that, I'll be using the Aerospike Helm charts. With Aerospike Helm charts, it's really easy to deploy an Aerospike cluster on a Kubernetes environment. It's just one single command, and your Aerospike cluster will be up and ready. So you can find the Aerospike Helm charts on Helm Hub. we have charts for both enterprise as well as the community edition. If you want to know more details on the chart, how the Aerospike stateful set is packaged, and what are the components that are involved, you can find those details in our GitHub repository. We have a repository for both enterprise as well as the community edition. Aerospike Helm chart supports different configurations of Aerospike. You can even apply your own configuration with this chart. There are a lot of different configurations, different features that are packaged with this chart. You can find all the details on how to use them. You can find examples. You can find the commands and everything. All the information, you can find it in this documentation. You can also find this documentation in our GitHub repo. So before deploying the Aerospike cluster using this chart, I have to add the Aerospike Helm repository. To do that, I'll simply copy this command and execute it in my terminal. So this will add the Aerospike Helm repository. This is the URL where all the Aerospike charts are hosted. And once I have added the repository, I can start deploying the charts. Now I'll go ahead and deploy the Aerospike Helm chart, which effectively means deploying the Aerospike cluster. So to do that, I'll be running Helm install, and I need to specify a release name. I'll specify it as submit. You can choose any name of your preference. Next, I need to specify the repository name, which is Aerospike, and the chart name, which is Aerospike Enterprise. The Enterprise edition requires a feature key file to start. So I'll specify the feature key file using feature key file path config option. And I can specify an absolute or relative path to my features.conf. And the next config that I'll be using is --set enable node port services equal to true. So this option instructs the Helm chart to create a node port service for each Aerospike pod, and these node port gets opened on the Minikube VM, and that way all the Aerospike pods gets exposed via an endpoint on the Minikube VM. The applications which are outside the Kubernetes network can easily connect and discover the Aerospike cluster from these node port and the Minikube IP. So along with this, I'll set another config called rback.create equal to true. So this simply creates a service account that has sufficient permission to query the node port service resource and fetch information like the randomly generated node port. So once I run this command, there will be a nice output on the terminal with an Aerospike rocket that says launched. And in the end, you can see a bunch of commands that you can use to get the information about the deployment. So now this output indicates that the deployment has begun, and I need to go and run kubectl get all to check the resources being created. And I can see the Aerospike stateful set created, and the 3 node port service for each Aerospike pod that gets created, and the Aerospike pods are slowly coming up one by one. So let's quickly go ahead and tail the logs from one of the Aerospike pod. So the cluster size is already 3. So we have all the 3 pods up and running, and they have formed a cluster. And let's scroll back up and notice this config, the alternate access address and the alternate access port. So the alternate access address is set to the Minikube VM IP, and the alternate access port is set as the random node port that the Kubernetes generates for us. And yes, so we have an endpoint that is exposed on the Minikube VM, and we can connect and discover the Aerospike cluster from outside the network. So our environment is up and ready. We have all the 3 Aerospike pods up and running. So let's quickly test the connectivity using the node port. So I'll be using a tool called ASADM, which is part of the Aerospike tools package to test the connectivity. So I'll specify the IP as minikube IP and the port as one of the node port. And I'll also specify an option called services alternate, which indicates the tool to use alternate access address for cluster discovery. So once I run this command, it's able to connect, ASADM is able to connect to all the nodes in the cluster, and our connectivity test is successful, and we have our environment ready. So I have my development environment ready with a 3-node Aerospike cluster running on Kubernetes, and the entire setup is running locally. Now I can start developing applications. And for this demo, I have created an example web application that can connect to this Aerospike cluster and perform some database operations. So before going forward, let me split the terminal into two tabs. On one side, I'll be connecting to the cluster using AQL to verify the data. And I'll be connecting the same way I did for ASADM, the minikube IP, the node port, and the services alternate option. So I can connect to my Aerospike cluster, and if I quickly scan the namespace, there is no data. And on the other tab, I'll be running my web application. So the inputs that go to my web application are through the environment variables. So I have specified the minikube IP as seed IP and one of the node port as seed port. And I have also indicated the application to use alternate services for cluster discovery, and the namespace and set to read and write data from, which is test and test set, test namespace and test set. So these are the inputs to my application, and I'll run my application now. It's a Django-based application which uses Aerospike as storage backend. So I'll be running it on port 8000. So if I quickly open localhost 8000 on my web browser, I can see the web application. So there's a nice message which says welcome to Aerospike Virtual Summit, and the app's name is Motogp registry, and it uses Aerospike as storage backend. So let me quickly go ahead and query some data. So if I click submit query for all bins, it internally does a scan, and it says no data found. And if I check the logs, it did scan and 0 records found. And I mean, yeah, so we also verified with AQL that there is no data in the cluster. So let me quickly go ahead and add an entry from the web app. I'll add myself, and let me give some 500 points and set me as rank 1. So I have inserted the data, and let's quickly verify in the application logs. Yes, it has successfully written the data and also read the data. And let's quickly verify from AQL. Yes, there is one entry added, and that's a new entry with me as rank 1. Okay, so let me also try another option which I have added, where I can bulk load data from Motogp site. So let me quickly go to some 2013. Let me get the championship data of 2013, and I'll simply copy this table and add it to a text file in my 2013. Okay, so I've added as a text file, and I'll upload the same through the UI, and I'll click upload file. The file has been uploaded, and Okay, so yes, I can also browse the file, and yes, so there's a message which says data has been written to Aerospike. So I should be able to see it if I do a scan. So I did a scan and I can see all the data. The rank 1 was Marquez. So yes, I can see all the data inside. So let's also verify from the application logs. Application has inserted some good amount of data. Normally it's, yeah, I mean, these are not added as info logging, but I just added it for this demo. And okay, so let's also verify from AQL. And I can see all the 27 data, 27 entries. Okay, so yes, so the application works. It can connect to the Aerospike cluster, and we can do a bunch of operations. The application is running from outside the Kubernetes network, and yes, so that's why I had to use the node port and the Minikube IP to connect, and the services alternate option. So another way to run my application is by packaging the application as a container and running it as a pod in my Kubernetes cluster. So I'll also demonstrate that method. I have already packaged my application as a Docker image using a simple Docker file. I have installed the dependencies, and there's an endpoint script that executes my application. And yes, so I have put my application on Docker Hub. So I'll go ahead and simply do kubectl run, and this will create a deployment and a pod that runs my application. So I've specified the deployment name as Motogp, and I'm using the image name. So this is the image that contains my application, and the port as same 8000, and the inputs to my application as environment variables. And if you notice, I'm not using the Minikube IP anymore. I'm using a service name because I'm already inside the Kubernetes cluster. I can discover the Aerospike pods by their name or by using a service name that resolves to one of the pod. So here, this service name Summit Aerospike Enterprise will resolve to one of the Aerospike pod. So I'm using the service name as my seed IP or the Aerospike host, and the port 3000 directly. I need not use the node port anymore because I'm already inside the Kubernetes cluster. So I'll directly use port 3000. The namespace and set name doesn't change, and the alternate services as false this time because I'm not depending on the alternate access address anymore. So let's go ahead and run this command, and the output says the deployment Motogp is created. So if I simply go ahead and do kubectl get all, I can see the new deployment for my app, which is Motogp, and a new pod which is running my application. So now my application is running. Let me quickly check the logs from the deployment. And yes, so it looks good. And now I have to expose the deployment so I can access it from outside. Kubectl expose deployment Motogp, and I'll set the port as 8000 because that's the port being exposed from the pod. And I'll specify the type as node port. So this will create a new service, which is of type node port, and there will be a random node port that gets selected, and this service will forward the traffic from this node port to my Motogp pod, and that way I can access the application. So let me go ahead and open this port with Minikube IP on web browser. So this is my Minikube IP, and I'll specify the node port, and now I can access the application again. So since it's the same cluster, if I simply go ahead and go to list riders and do a scan, I can see all the data back again, which we have loaded in the previous example, and I can query the data again. And yes, so the query is successful. So I've got the result of all the riders that belong to Team Yamaha. And let's also quickly check the logs of our application. So you can see successfully connected to the cluster, 27 records found because we did a scan initially, and the 5 records that returned from the query. So that's it. So this is also another way where we can package the application as a Docker image and run it as a pod inside the Kubernetes cluster.
So thanks for watching the demo. We have reached the end of the presentation. So I can take some questions via the QA chat box. I can see some questions there. So Balachandra has asked that can this be used for production grade performance? Yes, the Helm charts can be used for a production setup, and yes, a lot of features are there uh, which are of production quality in Aerospike Helm chart. And another question is Aerospike Kubernetes is it only for the dev use case? No, you can use it for production. We when we designed the Aerospike Helm chart and other Aerospike cloud components, uh, we we designed it make sure that it's production ready. And yes, so there's also another question from Ashish. How can I monitor the specific cluster stack during the development? So the Helm chart has an option where you can enable the entire monitoring stack, or you can also just deploy the Aerospike Prometheus exporter as a sidecar container, and that's you can integrate it with your own monitoring setup, which is Prometheus and Grafana based. So that's all. Hope I have answered all the questions. Thanks for attending this session. So if you have more questions, you can directly email me, or you can use the Slack channel for the virtual summit, and I'll be able to answer it on those medium. Thanks.